Okay, here we go. So if we want to find the point on the line y equals negative 3x plus 2, that's the shortest distance to the point 6 comma 5. We want to just kind of get an idea of what that looks like. So kind of going up 2 and down 3 over 1. So maybe our line's kind of going like this. And then the 0.65 is, somewhere over here, right? So 6 comma 5. So let me ask you this. What is the shortest distance between a point on a line? Like a point and a line, sorry. Would it be out to here, to this point? Would it be out to here, to this one? Would it be to here? Or would it be this one right here that is perpendicular? Probably the perpendicular one, you're right. So we want to find something that is eventually going to be perpendicular. So we can take a look at that idea, but that is definitely going to be the shortest distance. It will end up being perpendicular, so that's some way we can check ourselves. So let's call this point x comma y. Okay, we don't really know what it is. And if we're talking about the shortest distance, we're trying to minimize distance. So lots of different ways to kind of go through this one. We're going to talk about minimizing in this one and coming up with an equation and then looking for the minimum point. So if we're talking about distance, we should have a distance formula. Distance equals x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. So distance equals, let's take a look at our 2 points. I have 6 minus x, quantity squared, plus 5 minus y, quantity squared. And you're going to say to me, well, this is ugly because I have x's and y's. Well, whenever we have x's and y's and we want to reduce a variable, we want to look for some sort of relationship that connects the two. Well, that relationship is right up here. Y is connected to x by this equation, y equals negative 3x plus 2. So we can come into our problem, quantity squared, and we can replace y with the quantity negative 3x plus 2, quantity squared. Okay, now we just need to make sure we do some proper foiling. So I'm just going to make myself a little note here so that I can do this appropriately. And let me simplify here. This is going to be 5 plus 3x minus 2, which then gives me 3 plus 3x. And that quantity is going to be squared, which means I need to multiply 3 plus 3x again. So let's FOIL the first set. That's going to be 36 minus 12x plus x squared plus this quantity over here, which is going to be 9 plus 18x plus 9x squared. So then combining all of those, we have the square root of 10x squared plus 6x plus 45. So now we want to put that into our calculators and look for a minimum. So give me 2 seconds, I'll pull up on decimals for you. Okay, so graph that here, and that's what this graph looks like. You've got me on like how you're supposed to get a minimum. I believe this is the minimum here, the way it's graphed, and this is the intercept. I'm not as adept at Desmos as I am with my calculator, but in the calculator you do second calc and you calc for a min. So notice here that the x value is negative 0.3. So let's go back here. That means that this x value up here is negative 0.3 because it creates a minimum. So that's our x. Well, how do we find our y? Our y isn't the other value that was in this particular function. That's not what we're looking for here. That would give us a y for that. That's just our distance. We actually want to find the x value that goes with this. So how do I find the x value? Well, remember this relationship, y equals negative 3x plus 2. So y equals negative 3 times negative 0.3 plus 2. So put that in your calculator, you should give it 2.9. So this is y negative 0.3 comma 2.9. Oof, my graph was terrible. Don't judge. So just ends up being kind of goofy. So let's take a look at what that looks like. Otherwise, I'll pull up this other Desmos here. So you can see this is a much better graph. I think I put my y-intercept in the wrong spot in the last one. Do forgive me, that should have been plus 2. So here is the line that we graph, y equals negative 3x plus 2. The 0.65 was over here, and this negative 3 comma 2.9. So if you graphed a line that went in between those, you would see that it is perpendicular, and that's how we can find the point that creates a minimum distance. So if you have any questions, let me know.